Good morning, students. Magnetism will continue some questions with theory division. Okay. You are given a magnetic needle oscillates 30 times per minute at a place where the dip is 45 degree and 40 times per minute where the dip is 30 degree. If V1 and V2 are the total magnetic field at the two places, then V1 upon V2 is equal to question mark. To solve this question, you need actually two concepts. See, here it is. First one, elements of Earth's magnetism. Okay, elements of Earth's magnetism. First one is declination. It is, we can indicate by theta. Okay, what is meaning of declination? For example, it is Earth. It is its axis of rotation. Then it is called, it is its geometrical axis. It is called a plane which is passing from geographical axis. It is called geographical meridian. Earth having some magnetism, it is magnetic axis, okay, and it is magnetic meridian. Yes, it is geographical meridian. It is magnetic meridian. So first of all, what is declination? Declination is actually angle between geographical meridian and magnetic meridian at particular place. See, we actually know that if we suspend needle freely, okay, then it will align in north-south direction. Not exact in geographical north and south direction. It is like this, tilted. Okay, it is not exactly in true geographical north and south. It is actually like this. It makes some angle. It makes some angle like this. Okay, if it is true geographical north and south, then magnetic needle is aligned like this. Magnetic needle is aligned like this. It makes some angle, and that angle is called declination. That angle is called declination. Second one, D means y. Okay. In this case, see, it is angle, yes, declination is angle, it is made with true north and south. But what is it? It is angle made with horizontal. Angle made with horizontal. Okay. If at a point needle is like this, means it is in horizontal condition. So yes, here phi is equal to 0, that is dip angle is 0. But if needle is like this, okay, for example, if needle is like this, you can see it makes some angle. So here phi is not equal to 0. So it is called meaning of dip. Yes, it is meaning of dip actually. Then number 3. Yes, number 3 is the most important one. Okay, two components of Earth's magnetic field. Okay, say I will draw like this. Let it is one plane called magnetic meridian. It is another plane called geographical meridian. Okay, yes. Okay. Now, whenever we suspend any magnetic needle, that magnetic needle always aligns itself in magnetic meridian. In magnetic meridian. But it is, yes, it is in magnetic meridian, but it is not in horizontal direction always. It depends on location, okay. Yes, sometimes it is tilted with horizontal. So I can draw that needle like this, okay, actually. I can draw that needle like this. 3 number I will write here, okay. It will align like this, for example. Then yes, it represents direction of magnetic field. So see, magnetic needle aligns in magnetic meridian. It makes angle. It makes some angle with horizontal. That angle is called angle of D phi. So if it is magnetic field of Earth, we can say we can resolve it in two components. One in horizontal direction, one in vertical direction. This horizontal component is BH. This vertical component is BT. From here we can say BH is equal to it is B cos phi, and this BT is equal to it is B sin phi. Clear? BH is equal to it is BB cos phi, and BB is equal to it is BB sin phi. Clear? Okay. This component is towards magnetic north, and yes, this component is towards center of Earth. It is towards center of Earth. Now what happens? Okay, here. If you change any another plane, then in that plane, only horizontal component of magnetic field changes. Vertical component of magnetic field remains same. That is B. That is B. Okay. For example, yes, it is magnetic meridian. It is magnetic meridian. Okay. Needle is aligned in this direction, so it is B. So it is called, I can say it is BH. Here I can say it is BB. Okay. If I am taking this plane, any another plane, okay, so at angle some theta, then in this case, if we take two components of magnetic field, then yes, this one will be its horizontal component, and it is called BH cos theta. Okay, and this component though will remain same, that is BB only. That is BB only. So if you take another plane, then only horizontal component of Earth's magnetic field will change. Vertical component will remain same. Yes, vertical component will remain same. So this point you have to remember. Okay. Now one another equation. Okay, if a magnetic needle is suspended freely in magnetic field, then it will oscillate. It will oscillate means it will rotate. And yes, what is frequency or what is periodic time? Time period for that. So that equation is P is equal to it is 2 pi under root I upon mv. 2 that is 2, pi that is pi, I that is moment of inertia. Yes, what is meaning of I? I is moment of inertia. M magnetic moment of needle or whatever given magnet, and V that is magnetic field. Yes, B is called magnetic field. So here with the help of these two concept, we have to solve this question. Okay, chalo, we will try this question to solve. A magnetic needle oscillates 30 times per minute at a place where the dip is 45 degree. So chalo, for first one, a magnetic needle oscillates 30 times per minute. 30 times per minute. So for 30 rotation, it takes 60 seconds. So for one rotation or one times, what is time? Then yes, I can say that T1 is equal to, it is 60 upon 2. So it is 2 seconds. Clear? Per minute at a place where the dip is 45 degree. Where the dip is 45 degree, it means here what is horizontal component of magnetic field? BH1 is equal to it is. We can say what you are given per minute at a place where the dip is 45 degree and 40 times per minute where the dip is 30. If V1 and V2 are total magnetic field at the two places, then how to write? See, BH1 is equal to V1 cos, where it is, yes, 45 degree. Yes. BH1 is equal to, it is actually B1 cos 45 with the help of this equation. So BH is equal to B cos phi. Yes, BH is equal to, it is B cos phi. So with the help of this equation, we can easily write. Okay, so is equal to, B1 that is B1. B1 that is B1 cos 45 means it is 1 upon root. Clear? Similarly, we can write data for second. That is, it oscillates 40 times per minute. So we can write 40 times per minute means in 60 seconds. Then for one oscillation, what is time? then yes, T2 is equal to, it is actually 60 upon 40. 0, 0 per means it is 3 by 2 second. And in this case, BH2, that is horizontal component of Earth's magnetic field, BH2 is equal to, it is B2. What is angle? Yes, it is 30. So it is cos 30. So it is B2. So cos 30. Cos 30 is actually root 3 by 2. Clear? Now, if B1 and B2 are the magnetic field at the two places, then B1 upon B2 is equal to 1. Okay, sorry. Yes. T1, BH1, T2, BH2. Now, what is hint of this question? Hint of this question is this equation. It is equal to this 2 pi under root I upon n. Okay, so see here it is 2, that is constant, pi, that is constant, I. You are given a magnetic needle, only one magnetic needle, which is at different places. So yes, for only one, for a given magnetic needle, moment of inertia is constant. Also, its magnetic moment is constant. So we can say that T is proportional to T is proportional to 1 upon under root BH. Now, yes, there may be a question, sir, why BH? Why BH? Because here it is. Whenever you suspend magnetic needle, it will rotate in horizontal plane due to horizontal component of magnetic field. Due to horizontal component of magnetic field. So yes, this point you have to remember. Okay, whenever needle is suspended freely, it will rotate, it will oscillate due to horizontal component of Earth's magnetic field. So here we can write it is proportional to 1 upon under root BH. Okay, so yes, I can say T1 upon T2 is equal to under root BH2 upon BH1. Get it out? Now if I take square on both sides, then I can say BH2 upon BH1 is equal to T1 square upon T2 square. Now put values, okay, BH2. What is BH2? It is B2 root 3 by 2 divided by. What is BH1? It is B1 and here it is 1 upon root 2 is equal to T1. What is T1? It is 2. So it is 2 square divided by 2. T2, that is 3 by 2. It's square. Okay? Yes. So here it is B2 upon B1. I can write this root 2 in numerator. So it is yes root 3 into root 2 divided by is 2. And it out is equal to here it is 4 divided by what is square of 3? That is 9 divided by 4. So I can write that 4 here only. Clear? Okay. Now make B1 and B2 as subtract. So B1 upon B2. B1 upon B2 on opposite side. So it is root 3 root 2 divided by 2. 9 in numerator and 4 into 4 and 4 into 4. Now yes, you have to simplify this one. Okay, that is C 9 root 3 divided by 4 into 4 means 16, and I can write this as root 16 root 2. So it is value of B1 upon B2. Yes, it is value of B1 upon B2. Simple. Okay, so see, to solve such questions, sometimes you need more concept. Okay, yes, here you have to remember this case also and also this equation. Then you can solve these types of question. Okay, now next question. Okay, now next question. The time period of a magnet in vibration magnetometer is 2 seconds. The magnet is cut along its length into 3 equal parts, and parts are then placed on each other with their like poles together. The time period of this complication is, see, understand question. You are given a magnetic vibration magnetometer. Okay, suppose it is magnet. Suppose it is magnet. Its pole strength is P. Its length is L. Okay, so you are given one magnet. Okay, its pole strength I can say it is P. Its length I can say it is L. Its mass I can say it is capital M. Okay, so what is its magnetic moment? Magnetic moment M is equal to, it is P into L. Yes, what is the equation of magnetic moment? It is P into L. What is its moment of inertia? What is moment of inertia? Yes, we can assume for this magnet, or you will be given that this magnet having length, it is greater than its width and breadth. Okay, so moment of inertia I for a thin rod we can say it is M L square by 12. But this one M is mass. Okay, so first of all you have to remember these each and every points. Pole strength P, length L, mass M, then magnetic moment small m is equal to, it is P into L. Moment of inertia is equal to ml square by 12. And if yes, magnetic field is P, then what is the equation of time? That is T is equal to 2 pi under root I upon mb. 2 that is 2 pi, that is pi. B that is magnetic field constant. I here what is I? It is ml square by 12. M what is I? It is P into L for this given. Okay, and yes, you are given that this T is equal to here 2 seconds. Now what is our question? The magnet is cut along its line into 3 equal parts, and parts are then placed on each other with their like poles together. Yes, 3 equal parts. 1, 2 and 3. 3 equal parts like this. So obviously you will get 3 magnets like this, having pole same, pole strength same, but length will be L by 3. Mass will be M by 3. Clear? For each part, okay, for each part, length, and here it is mass. Okay, they are placed with their like poles together. So it is N. Here it is S. So for each and every part, magnetic moment having same direction. So what is resultant magnetic moment? Resultant magnetic moment M dash is equal to, it is 3 times. Why I am writing 3 times? Because like poles are placed on each other together. So for each and every magnet, the direction of magnetic moment will be same. So you can directly, okay. So M dash is equal to 3. Now what is equation of magnetic moment? Okay, pole strength into length. Pole strength will remain same, that is P. What is length? Hello. What is length? Length of each part it is L by 3. Length of each part it is L by 3. Clear? Okay, so yes, here what is the poles? What is the magnetic moment? It is 3 current and it is P, so it is M only, and this is equal to M. So there is no change in magnetic moment. Yes, there is no change in magnetic moment. Now what is changing? Moment of inertia. See, what is changing? Moment of inertia. Again, moment of inertia I dash is equal to 3 times. Why 3 times? Again the same concept. You have divided these 3 parts into 3 equal parts. Okay, so 3 into M. What is mass of each part? M by 3. L. What is length of each part? Capital M. Okay, it is L by 3 whole square divided by, here it is 12. Okay, so is equal to, I can say this 3 cut, this 3 cut. Okay, so in numerical it is M L square divided by this 12 as it is, this 12 as it is, and this 12 means it is 9. Now ml square by 12, ml square by 12 means it is I. So I can say I dash is equal to, it is I by 9. I dash is equal to, it is I by 9. Magnetic field will remain same at that place. Okay. Now you know equation, that is what is equation? T is equal to 2 pi under root I upon mb. For new magnet, for new system, I dash T dash is equal to 2 pi I dash m dash b. And T dash is equal to this 2 pi under root I dash m dash b. Is equal to 2 pi. What is I dash? I dash means it is I by 9. M dash means it is the same one, okay? M. and here it is B. And it out. And it out. Now see, this 9 you can write in denominator, and if you take its square root, I can write like this. It is 1 upon 3. Here it is 2 pi under root I upon mb. But what is 2 pi under root I upon mb? That is t. That is t. So it is t by 3, or I can say it is 2 pi. Yes. Or I can say it is 2 pi. So yes, it is your answer. Okay. Now you can be asked different type of question. Okay. Okay, these 3 parts are placed such that their polarity is opposite. Or alternative. Alternative means one north south, one south north, and one north south. And this magnetic moment changes actually. Okay. This magnetic moment changes. Otherwise, this moment of inertia will remain same because it is scalar quantity. Clear? Okay. So yes, this is it for today's lecture. Yes, this is it.